Hello everyone, and welcome to my second online tutorial for Mechanics 1. My name is Kevin, and today I'll be talking about transformation matrices, and then a little bit of linear algebra regarding determinants of a matrix, matrix multiplication, subtracting matrices, the transpose of a matrix, and then I will solve a problem regarding orthogonal transformations. But today we'll go a little differently than the first tutorial because today I'm just going to be going straight through problems rather than explaining the material beforehand, because you should be able to pick up a lot of the material from lecture. So let's get started. So our first problem is 1.1 out of the textbook from Marion and Thornton. So you want to find the transformation matrix that rotates the axis x3 of a rectangular coordinate system excuse me, 45 degrees toward x1 around the x2 axis. Okay. So for anyone who doesn't know, the x1, x2, and x3, those can be thought of as x, y, and z coordinates. Or if you're talking about spherical coordinates, it could be r, theta, and phi. But they are rectangular coordinates, so they're orthogonal to one another. But just so you don't get confused right off the bat, x1, x2, and x3 is just a generalized coordinate system. So the first thing that I usually do is draw a picture. So let's draw our three-dimensional coordinate system. Well, I'll denote this one as x3. I'll denote this one as x1, and I'll denote this as x2. And then we want to rotate the x3 axis 45 degrees toward x1. So we want to go and we want to look for a new axis, call it x3 prime, where this is 45 degrees. And you can see that we've moved toward x1. And we're also lying in the x1, x3 plane. So this vector here is orthogonal to x2 because we're rotating around it. But when we do this, of course, x1 will be affected because we still want to keep our coordinate system rectangular. So this vector will also lie x1 prime. So this will also be 45 degrees to keep our coordinate system rectangular. And yeah, that's about it. So I just want to write a quick note here. We're going to note x1 prime and x3 prime lie in the x1, x3 plane. So all that means is that the plane spanned by x1 and x3, the x3 and the x1 vectors will lie inside of that plane and they'll be orthogonal to the x2 vector. Okay, so since they're lying in the plane and really x2 is unaffected by this transformation, so we really don't have to worry about it, we can just draw out a 2D system to make it a little more clear. So I'll label that x1 and this x3. So really, our new vector here, I'll choose a different color. And I'll choose green. So our x3 prime vector will look something like this. And there'll be an angle of 45 degrees from the x3 axis. And then there's also, that a little better. And there's also x1 prime, which will also be, so this is 45 degrees here, and this is 45 degrees here. So now we want to describe our new coordinate system with respect to our old coordinate system. So the way we want to do this is we want to rotate this so that x1 and x3 are our new axes. And then we want to describe the x1 and x3 vectors with respect to the x1 and x3 axes, or the x1 prime and the x3 prime axes. So if you kind of tilt your head to the left a little bit, then we can get these following expressions for x1 prime and x3 prime. Okay, so we want to tilt our head, then we want to describe x1 prime with respect to x1 and x3. So if we look at it, we'll find that in order to get this y, in order to get the y component of x1 prime, which will come from x1. So in order to get this part of it here, so this is just the cosine of x1 with 45 degrees. So this is x1 cosine 45 degrees. And then in order to get this component here, we need to describe it in terms of x3. So when we do that, we will have negative x3 and then we want to take, when we take the cosine of this, then we'll get the horizontal component for our x1 prime. So that's x1. We know that x2 prime is just equal to x2 because I'm not doing anything to it. And then x3 prime will have to be, if we again look at x1 here, so we want to describe x3 prime in terms of x1 and x3. So when you do this, you want to look at x1, and if you take the cosine theta of x1, or cosine of 45 degrees, then you will get the horizontal component, or you'll get the vertical component for x3 prime. So this will be x1 cosine 45 degrees, and then we'll also have to add x3 cosine 45 degrees. And this will be our coordinate transformation. Okay, so now if we use cosine of 45 degrees equals 1 over the square root of 2, then our equations become minus x3 over the square root of 2, x2 prime equals x2, and x3 prime equals x1 over the square root of 2 plus x3 over the square root of 2. Or if we write this in matrix form, x1 prime, x2 prime, x3 prime. So if we write this as a column vector, this must be equal to our transformation matrix here, which will be x1 prime equals x1 over the square root of 2, so this will be 1 over the square root of 2. There's no x2 component here, and then we'll have negative 1 over the square root of 2. For x2 prime, we just have x2, so we'll have a 1 here, and there's no other components, so we'll put zeros, and then x3 prime will have 1 over the square root of 2, 0, and 1 over the square root of 2. So this is our transformation matrix. And then, of course, we have to multiply by a column vector. And this column vector is the original coordinate system, x1, x2, x3. And there you go, there's your transformation matrix for this problem. So really, the hardest part is really writing down these equations here. And you have to draw this picture out so you can actually visualize what the primes will be built out of, because they'll be built out of the original coordinate system. So you really just have to find the components of your new coordinate system through the old coordinate system. Okay. So that is the first problem that I wanted to go over for this tutorial. The second problem is also from the textbook, so we have 1-14. So this question says, consider the following matrices. So we have A, which equals this. We have 1, 0, 2, 2, 3, 0, and negative 1, 1, 1. So here we have a 3 by 3 matrix. Try to remove that. B. It's also a 3 by 3 matrix. So we have 2, 0, 1. We have 1, minus 1, 1. And we have 0, 2, 3. And then lastly we have C, and this is a 2 by 3 matrix. So we have 2, 1, 4, 3, 1, 0. Or sorry, this is a 3 by 2 matrix. So this is 3 by 3, 3 by 3, and 3 by 2. Okay. So the first, I'll write down all the questions here. So first thing they want us to do is they want to find the determinant of A times B. Second thing they want us to do is find AC. Third thing is A times B times C. And lastly, They want us to find A times B minus B transpose times A transpose. Okay. So let's start off with A. So the first thing we want to do is we want to find A times B. So if we do A times B, so this equals this matrix here, which I can hopefully select. And of course it won't let me select it. Let's rewrite it. So we have 1, 0, 2, 2, 3, 0, negative 1, 1, 1, multiplied by 2, 1, 0, 0, negative 1, 2, and 1, 1, 3. Okay, so since we have a 3 by 3 matrix here and a 3 by 3 matrix here, we're expecting that we're going to get also a 3 by 3 matrix. And the way we do matrix multiplication is we'll select this row here and multiply by this column here and do the dot product between this column. So when we do that, we get, we'll have 1 times 2. Yes, we'll have 1 times 2 plus 0 times 2 plus negative 1 times 1. Well, I'll just rewrite this. So we'll have this element multiplied by this, we'll have this element multiplied by this, we'll have this element multiplied by this, and then we want to add them all together after multiplying. When we do this, we'll get 2 plus 0, and then minus 1. So that will be our first row, first column element. And then we want to take this and multiply by the middle row. So then we'll have 1 times 1, we get 1. We get 2 times minus 1, we get minus 2. And then negative 1 times 1, and we get minus 1. We'll do the same thing. We'll take this row here and multiply by this column here. And then we'll get 0 plus 4, 2 times 2, and minus 3. And those will be the elements for the first row of our new matrix. So then what we want to do is we want to take this row and multiply by this column. And then once we go through all the columns, we want to take this row, multiply by all the columns, and we'll have our matrix. Okay, so this element here will be 0 times 2, which is 0, 3 times 0, which is 0, and 1 times 1, so we'll have 0 plus 0 plus 1. And then we'll have 1 times 0 is 0, minus 3, and plus 1. And then we'll have, for the last element here, we'll have 0 times 0, which is 0, plus 6, we get 2 times 3, and then plus 3, and 3 times 1. Okay, then the last elements here, we have 2 times 2, we get 4, 0 times 0, you get 0, and 1 times 1, you get 1. And then we'll have 2 times 1, you get 2. 0 times minus 1, you get 0. And then 1 times 1, you get 1. And the last element, we'll have 2 times 0, you get 0, plus 0 times 2, you get 0 also, and then 1 times 3, so you get 3. So therefore, our AB is equal to 1 minus 2, 1, we'll have 1 minus 2, 9, we'll have 5, 3, and 3. Okay. So this is our matrix here. Now we want to find the determinant of AB. So we'll go here, AB. This just means determinant. We want to write it like this. We're going to have 1 minus 2, 1, 1 minus 2, 9, and 5, 3, 3. So this is the exact same process as we do with cross product. So we'll get AB equals 1 times the determinant of this 2 by 2 matrix here, so we get negative 6 plus 27 will be minus 27, so minus 6 minus 27. We'll have a minus sign here of minus 2, so that becomes a plus 2. And we want to do the determinant of this 2 by 2 matrix here, omitting the middle column. So 1 times 3, so you get 3 minus 5 times 9, which is 45. And then lastly, we'll have plus 1 times this determinant of this matrix here. So 1 times 3, so you have 3. And then minus minus 10, so plus 10. And this will be the determinant. So if we work this out, just make sure I did everything right here. Did I forget a minus sign somewhere? Nope, looks like I did everything right here. If you work this out, you should get an answer of 104. Okay, so that was the first step. The second question asks us to find AC. So I'll take this here, I'll copy this. I'll just erase this here. AC. Then I'll try and copy C matrix. Good enough. And I'll bring this down. Okay. So as you can see, if we look at the dimensions of this matrix, in order to matrix multiplication, these two numbers have to line up. And then the size of our matrix as a result from the matrix multiplication will be a 3 by 2 matrix. So we'll get this matrix over again. The size of that matrix over again. Okay, so we want to do the exact same thing as above. So when we do this, we'll have 2 plus 8 minus 1, and then we'll have 1 plus 6 plus 0, and then we will have 0 plus 12 plus 1, and then we'll have 0 plus 9 plus 0, and then we will have 4 plus 0 plus 1, and then we will have 2 plus 0 plus 0. And when we work this out, we get that AC equals we'll have, oh, did I do a little something here? Whoops. Okay. We'll have 9, 7, 13, 9, 5, 2. Okay. So that is AC. So now we do part C, which is, A times B times C. But since we've already found A times B, we can just take that matrix that I found up here. Wait, AB equals this. So I'll copy that. We can just find AB. And then multiply that by C. So we've already found AB, we know it's this. So ABC then is just this matrix here. See if I can select this. Why are you doing that? Okay, so it's just this matrix here. Multiplied by the matrix here. So we have 2, 1, 4, 3, 1, 0. Multiplied by that matrix there. And when you work this out, again we'll get a through by 2 matrix. So 1 times 2 minus 8 plus 1. And then we'll have 1 minus 6 plus 0. And that will be it for that row. And then we'll have 0 plus 12 plus 1. Wait, what? Oops. There are 2 minus 8 plus 9. There plus 1. Just work it out. 2 minus 8 plus 1. Oh, it's 9, sorry. And then I'll have 1 minus 6 plus 0. And then for the last row, 10 plus 12 plus 3 and 5 plus 9 plus 0. Okay, so when you work this out, you get a 3 by 2 matrix. -5, -5, 5, -5. I mean, this is 3. Yes. This should be a 3. 25 and 14. Okay. So that's ABC, and then lastly, we want to find A times B minus B transpose times A transpose. So again, we already have AB here, so we just copy this matrix here, and then we just need to find B transpose A transpose. So B transpose, if we look at, and then maybe I'll copy B and A down here, so then we can look at the transpose directly. So I'll try and select this. There we go. Bring it back down. So there's the 2 matrices there. So if we look at A transpose, or B transpose, A transpose, we want to write down B first, so we'll have 2, 1, 0, 0, -2, 2, and 1, 1, 3. So that's all we have for B transpose, because all we're doing is taking the rows and turning them into columns. So this row becomes this column, this row becomes this column, and this row becomes this column. Okay. Now A transpose, we do the same thing. We'll have 1, -2, -1, 0, 3, 1, and 2, 0, 1. So now we do this matrix multiplication, and we get a 3 by 3 matrix. So we'll have 2 plus 0 minus 1. We have 0, 0, 1. We'll get 4 plus 0 plus 1. We get 1 minus 2 minus 1. We get 0 minus 3 plus 1. Then we get 2 plus 0 plus 1. And then we get 0 plus 4 minus 3. 0 plus 6 plus 3. And lastly, we get 0 plus 0 plus 3. When you work all the arithmetic out, you get a matrix of 1, 1, 1, 5, negative 2, negative 2, 3. And 1, 9, 3. Okay, so now we want to compute AB minus B transpose A transpose. So then all we're going to get, we just want to take the individual elements and subtract them from one another, and then we'll get, so we get 1 minus 1, we get 0, negative 2 minus 1, we get minus 3, 1 minus 5, we get minus 4, 1 minus minus 2, we get 3, negative 2 minus 2, we get negative 4, 9 minus 3, we get 6, 5 minus 1, we get 4, 3 minus 9, we get negative 6, and 3 minus 3, we get 0. Okay. Wait a sec, this should be 0 here. We get minus minus. And that's it for this question. Okay, so just to review, we did a lot of matrix multiplication, which is helpful to get it in our head and make sure that we know it forever. We looked at the determinant, which is just the cross product of 3 vectors, essentially. And then we looked at the transpose of a matrix and some matrix subtraction. Okay, so the last problem that I want to look at, relatively short, so it's problem 1-15 from the text. We want to find the values of alpha needed to make the following transformation orthogonal. So we want to have A equal this transformation matrix. So we have 1, 0, 0. And we'll have 0, 0 here. So we can see that x1 will be unaffected from this transformation. Alpha, negative alpha, alpha, alpha. So this is our transformation matrix here. And then we want to find the values of alpha such that this transformation matrix is orthogonal. So if we want A to be an orthogonal matrix, then we want the following. We want to have A transpose times A equals I. So if we do this, where I is the identity matrix, in this case it'll be a 3 by 3 identity matrix. So if we write down A transpose A, we'll get the following matrix multiplication. So we'll get 1, 0, 0 written here. And then we'll have 0 alpha minus alpha and 0 alpha alpha multiplied by 1, 0, 0, 0 alpha negative alpha and 0 alpha alpha. And this must be equal to 1, 1, 1 down the diagonal and zeros everywhere else. So this is the 3x3 identity matrix. Okay. So let's do this matrix multiplication. So when we carry out this matrix multiplication, we'll get the following. We'll have just 1 plus 0 plus 0 for the first element, and we'll get a 3x3 matrix from the matrix multiplication. We'll get 0 plus 0 plus 0. And we'll get the same thing for the next one. And for this row multiplied by this column, we also get 0 plus 0 plus 0. And then we'll get alpha squared minus alpha squared. Or that should be a plus, sorry. And then now we'll have minus alpha squared plus alpha squared. And then for the last row, we will have 0 plus 0 plus 0 once again. And then we will have negative alpha squared plus alpha squared. And here we will have alpha squared plus alpha squared. If the minuses will cancel out. And this is still equal to our identity matrix. Okay. So when we look at this, we'll find we get this matrix here. So I'll just set this equal over here. So I'll just take this matrix and put it over here. So we'll get 1, 0, 0. We get 0, 2 alpha squared, 0. And we get 0, 0, 2 alpha squared. So in order for this to be true, so we know that 1 is equal to 1, which is good. But then we need 2 alpha squared equal to 1, which means that alpha must be equal to plus or minus 1 over the square root of 2. And that is it for this question. So in this question, we provoked this identity here in order to solve for the alpha values. And that is it for the tutorial for this week. Thank you.